Hello. Welcome to this evening's TI Technology webinar hosted by Texas Instruments. We'll take a look at how the TI-Nspire Navigator System can help you implement the Common Core mathematical practices. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all students. I'm very happy to introduce our two panelists tonight, Katie England and Jeff McCalla. Katie is currently a mathematics content specialist for grades pre-K through 12 at Montgomery County Public Schools in Maryland. She has served in a supervisory capacity for secondary mathematics teachers at the district level and continues to work with the Maryland State Department of Education on statewide mathematics initiatives. Thanks for being with us, Katie.
Thanks, it's great to be here.
And Jeff co-founded the TI-Nspire super user groups with Bryson Terry. He teaches Algebra 2 and Pre-Calculus at St. Mary's Episcopal School in Memphis, Tennessee. In 2009, Jeff received the Presidential Award for Excellence in Mathematics and Science Teaching. Jeff was also on the Pearson Project, writing TI-Nspire documents for the 2011 edition textbook, and he also authored the second edition of the TI-Nspire for Dummies book. Thanks for joining us, Jeff.
Hey, it's great to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also send general messages in the chat window. Once we move to the software, the right section of your screen will be replaced with a green floating toolbar, and you can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with your handheld or your software, and we really hope you will, we do recommend doing this with the recording. That way you can download the activities and pause and rewind the recording as necessary. We don't expect you to have any audio issues tonight, but in the event that you do, choose Audio Broadcast in the WebEx menu and click Join. At this point, Katie is going to discuss our agenda.
Hello again, everybody. So tonight we're going to focus on the Common Core state standards for mathematical practice, and we're going to do so trying to take a focus on the Navigator capabilities of the TI-Nspire Navigator software. We're going to take a look at a Math Nspired activity based on the standard form of quadratic functions, and we're also going to take a little peek into some statistics looking at regression models and how those help us make decisions about the data we collect.
Thanks so much. And Jeff is going to discuss our expected outcomes.
So we're going to explore how we use in our classrooms the class capture, like how we can look at screens of students' handhelds during class and how that works with discussion with students. It kind of opens up discussion. We're going to learn how to use the quick poll feature to get answers from them somewhat quickly, get data, and we might even tell you what we can do with that data once we get it. Which is kind of interesting as well. And then we want to stay in touch with you, and so please use social media to contact us, and we are doing a better job of that as instructors as well, as far as keeping upcoming with. There's lots of events coming up. Even the summertime we have webinars, and so this is a great resource for you, and we appreciate some of you who are here for the first time to your first webinar.
Thanks, Jeff. And Katie, go ahead and share your desktop. And as Katie does that, I just want to mention that chat window, which some of you have been using a lot, and also the Q&A window, which were on the right side of your screen, are again now underneath that green floating toolbar. So if you want to bring up that chat window, because I think Katie and Jeff are going to be maybe asking some questions, they might want you to respond. Feel free just to use your mouse to hover over that green floating toolbar. Go ahead and click the chat icon, and I'll bring up the chat window. The Q&A window is also located underneath that eject-looking button. So go ahead and bring up both those windows. And one more thing, I see a lot of people that are already using the chat window, which is really great to see. We have one choice that we're really looking for whenever you send your chats, and that would be a send to all participants. Some people are just using all attendees, which I believe is the default. And the issue with that is that Katie and Jeff don't see your chat. So whenever you're chatting, go ahead and use all participants. That way everyone sees it. Katie, it's all yours.
Thanks. Yeah, Jeff and I are really looking to see how all of you are talking to us, so please use that to all participants so that we can see what's going on. How you doing, Jeff?
I'm doing all right. So I like your question there. What do students use, think about, and do?
Good.
Is that your question? Did you come up with that?
Actually, believe it or not, is not my question. I picked this up at a workshop that I went to for some other district leaders. I'm really strong and really believe that we need to continue to think about the standards for mathematical practice. You know, it was really big when the Common Core first came out, and we spent a lot of time really digging into them because we didn't know what the content standards were going to look like in our classroom yet. But as we start digging into new curriculum, we're getting further and further away from these. And a lot of times as teachers, it becomes such habit that we just refer to the standards for mathematical practice by the titles. But I think that it's really important for us to continue to check in with what do these really mean instead of just looking at the titles. And so when this first came out, we all sort of got into the habit of, okay, well, you can go through and you can circle the verbs and what are the key phrases. And at a workshop I was at recently, somebody came up with a new strategy for how can we get our teachers and all of us, get our students to look at these standards for mathematical practice through a new lens. And so with that question, what do students use, think about, and do, we're going to take a minute here to start our webinar looking at the standards for mathematical practice through that lens. You'll notice that I did put the link up here for where you can retrieve the standards for mathematical practice because we're going to try to refer to them tonight, so you might want to pull that up so you can refer back to it. So what do students use, think about, and do? If we take a look at the standard for mathematical practice here, attentive precision, there's a lot of text in here. And so what I'm going to ask you to do, I'm going to put another one up in just a minute, but I'm going to ask you to look through the text and see what is the standard for mathematical practice asking students to use. So here students are using clear definitions. They are stating the meaning of symbols that they choose. They might be thinking about the units of measure. They might be, again, calculating efficiently and accurately, and degree of precision. So what do students use? What are they thinking about? And what do they do? And so I'm going to put up another standard for mathematical practice, and I'm going to ask you all to put in the chat window what you think students use, think about, and do based on this text. And I'm going to trust the gods of all of you all thinking out there that some of you will do what students use, others of you will do what students think about, and some of you will concentrate on what students do.
You know, Katie, can I be honest? The only time I almost always read bulleted list of the standard math practices. You're the only person that makes me read the original manuscript. I feel like I'm going back to, this is the Constitution or something. No one ever reads this.
Well, yeah, and it's not easy to read, so we need to be real about that. It's not easy to read, and so you do see a lot of bulleted lists out there. But what ends up happening is that it ends up into a checklist, or again, we just forget about that, and so we just go back to what that title is, and we lose the richness of what that original text really means. Is anybody out there putting in what students use, think about, or do? Students think about what all the numbers mean. Good. Evaluate reasonableness. Yes, and I'm not reading fast enough to be able to see where that is.
It's near the bottom, I think, the very last line.
Yes, there it is. Evaluate reasonableness.
Students just want to be able to get the answers. Now, there's an honest, John says, my students just want to be able to get the answers.
Which is why it's so important for us to make sure our students understand that they're assessed on these standards for mathematical practice. I don't know about how many of you out there are Park states or Smarter Balance states or some of those states that are even moving towards their own standards and own assessment systems. I know that I'm a Park state, and we are going to be specifically assessed on the standards for mathematical practice. They're going to use securely held materials, so material from prior years. So if I'm in 7th grade, they might use 6th grade content, and they're going to assign me a score, determine how proficient I am on my standards for mathematical practice using old content.
So Deborah says they use pattern recognition, which is true. I think students, you know, they somewhat naturally have that ability to see those patterns and recognize those, I think.
Very good. So if you look in here at this repeating decimal phrase, there's some patterns happening there.
Yeah. Daniel says they're looking for shortcuts. What do you say to that, Katie? Do you think students are always looking just for shortcuts?
I think that they are always looking for shortcuts. I think how we ask them to do that can be a good thing or can be a not so good thing, depending on how we're going about that, what questions we're asking our students.
Yeah, yeah.
So I'm going to go ahead and move us on. Now that we're grounded in what the standards for mathematical practice are and what they say, and again, I encourage you, even with your students, to go back and look at what this rich text has to say for us. And tonight we're going to talk about, we're going to start by looking at a Math Nspired activity. So this is a free activity already constructed for us with student worksheets and so forth, and we're going to be using those things tonight. I'm going to walk us through this activity that's dealing with the standard form of quadratic functions. And a big question for this to keep in the back of your mind is, how do the parameters in the standard form of a quadratic equation determine the shape of the graph? So Jeff, how often do you use these Math Nspired activities in your classroom? Do you find them useful?
Oh, I mean, yeah, these are great. And, you know, the nice thing about them, they come in Word documents and PDFs. So sometimes you can take bits and pieces of them and make them your own. I like doing that. Or sometimes even just using the questions or using the Navigator ideas that are in there to enhance my lesson just a little bit more. And this one's particularly interesting because I think in general, we tend to not use the standard form that often. We use vertex form, what I call vertex form, quite often with quadratics, but we don't always talk too much about standard form.
Right. So this opens up a really good opportunity for students to look at a different representation of the quadratic and see how the different parameters do that. It opens great opportunities for standards for mathematical practice. So I'm looking at the student page here, so this was already done. I do have the Word file open, so you'll see that there's some things bolded in here. That's to help me for tonight, so that just gives you one example as to how you can modify these. But you'll notice that essentially what students are going to be doing is looking at a document, and they're going to be playing with the parameters A, B, and C. And they have a table here on their student page that's going to help them capture, when they change the value of A, what happens to my coordinates. So it would probably be helpful if we could actually see what this file looks like. And so here's this file. And students are first asked to go ahead and play with this A value and move this A value around. And if you remember that table, they're filling in this table and keeping track of, okay, how did I change my A value and what's happening to that P coordinate as I do so. And you know,
the X value is staying at 2 every time you move it.
It sure is. And
so
what's happening to that Y value?
Okay.
The Y value is changing. Now the question is how much? So here's where it's really great for students to be able to analyze some data. So here's where your Navigator comes in. I've created a quick poll. So this is essentially a question that I created that I'm able to send to my students. And I'm asking students to essentially recreate that table. And when I send it to them, they have the opportunity to put in an A value that they recorded and the corresponding X and Y values and so forth. And the way I have it, when I click Start Poll and I don't have it started here, they can put in as many coordinates as they wish.
Ooh, that's
and
nice.
So this is a sample of what I got back when I did something like this in my classroom. So students were able to put in all of their A values and the corresponding X and Y values. So now they're not just looking at what they're doing on their screen, but they see what everybody has done.
So you get everybody's answer, not just one person.
I get everybody's answer.
It all comes into the list there, okay.
Right. So this only looks like it's a couple of students, but if I have a class of 30 students, I have at least 30 data points. But actually, in this particular one, these first 3 entries were done by one student, and they were ambitious and had enough time, and they wanted to put more information in there. Yeah. What's really nice about this is not only can I collect that information, but I can copy and paste it into a spreadsheet, and now I can send this document back out to my students. So in my students' handheld, each and every one of them has the entire class list of data that they can look at.
Mm-hmm. So you aggregated.
Jeff, do you see anything interesting happening here with that list 3, or which is technically the Y coordinate, as related to the A value?
Okay, so 1.2 is divisible into 4.8 there. Is 1.4 divisible? Let's see, 5.6 divided by 1.4. Is that divisible there? 2.8, yes, it is.
Yeah, so maybe I can pull up the scratch pad. So what did you just say?
5.6 divided by 1.4.
That was interesting.
And was it 4.8 divided by 1.2, I think?
4.8 and 1.2. What do we think's happening here?
It's a direct relationship, right?
It sure is. So what I'm seeing happening to my Y coordinate is I'm seeing that my Y coordinate is equal to my A value. Oh, somebody just put that in the chat room. They're noticing that my Y coordinate is my A value times what that original coordinate was, and that original coordinate was 4. If I put my A value back at 1, I can see that original coordinate. So with my students being able to analyze that data, they're able to make those connections. And so this is a great example of mathematics. Go ahead.
John had an interesting question. He says he wasn't sure if his students would be able to see that or not. I think if you led them like you just led me, like Kitty just, kind of said, the A value and the if you kind of lead them like that, I think that they'll make some of those connections with patterns. They're actually, I think students are pretty good about that. If you ask the right questions, I really think it is a lot about questions.
It is a lot about questions. I think it's also, they might not be able to do that at the beginning of the school year, but if you're really diligent about teaching them this mathematical practice, especially the ability to persevere in problems and how do you attack a problem and what kind of patterns do you look for, they will be able to get there. And then you have those questions in your back pocket to help, scaffold that along to let them get there. But I think the biggest benefit to this is that we're really talking about a standard for mathematical practice here. When we look at this, and the students are able to analyze and look for those patterns, they're looking for regularity and repeated reasoning. So if we think about the text that was in that standard that we just looked at, they're noticing those calculations that are repeated. They are overseeing the big problem of what's happening with A while they're attending to those individual details. And they're generalizing what's going on. All of that is language from that standard for mathematical practice that we looked at just a few minutes ago.
And Mark is making a point. He says that the parent function, and I think he has, maybe there's a connection with the point 1, 4, and the fact that we're multiplying that A value by 4 there. Or 2, 4, I think, or maybe the 2, 4 point.
Absolutely. What are we doing to that parent function? We're dilating that parent function. So this is a great conversation about your transformations, and that's the whole point of looking at the parameters here. Now, I want to take you forward to another spot in this student worksheet. The very next question says, Lisa says that when A is less than -1. So now this student page is wanting us to think about what those A values are, less than -1. And I have to tell you, I was doing this with my son who's only in grade 4, and he thought that was the coolest thing ever when I was able to change that and he was able to make some predictions. But I would say that even before we we take a look at this, I would ask students to make a prediction. What do you think is going to happen when A is equal to -1? And I could collect data on this with a quick poll, but I'd like to ask the audience, everybody that's kind of paying attention here, in the chat window, which standard for mathematical practice do you think that might be if you're asking students to make a prediction and then talk about why it is that they made that prediction to justify their choice? Ooh, we have Daniel that says Math Practice 2. I'm pretty sure that's the one. I'm not real good about the numbers, but I'm pretty sure that's the one about reasoning quantitatively. I think that's a great choice. Anybody else want to weigh in? So Jeff, do you have any thoughts of which one you might think?
Well, I mean, maybe construct viable arguments, possibly critique the reasoning of others because you're all talking there. Could be
absolutely,
things.
absolutely.
You're using
I think
appropriate tools strategically. You're using your calculator in a strategic manner.
Right. So look at how many different standards for mathematical practice we can get from that one question. Just for a piece of information, I thought that it was let me try that one again. Constructing viable arguments and critiquing the reasoning of others, because you really are kind of having that argument. But I think any one of those is the perfect way to take that conversation.
I do like the reason that quantitatively there was really.
I like that too. I hadn't thought about that. I like that too.
Yeah. Yeah.
So real quickly, another one that I think is a great way to think about another mathematical practice is this very next question. And it's asking students to summarize what they just learned about that A value. Here it's asking students to explain the effect that A has on the graph, and so it wants them to kind of write a rule. So what are most students going to say there?
When A gets big, it gets skinny, or it stretches, maybe?
Absolutely. Some of them would say not only when A gets big, but a lot of my students would say when A gets bigger than 1, and it'll stretch, it'll get skinny. But we just saw that it's not only when A gets, is increasing a greater than 1 in positive direction, but also in a negative direction. So here's a great chance to bring in attention to precision, where you can have students talking about if A is the absolute value of A is greater than 1, then your function is dilated vertically. So listen to that language that you want your students to be using there. Perfect.
Well, I would love it if my students would say the absolute value A greater than 1, it's dilating or stretching. I mean,
I would love it too. Really, my students, they would never do that without me prompting them, but that's me having to purposely plan for them to attend to precision. It doesn't just happen on its own. We have to make sure that they're aware that they need to be doing that.
Yeah.
So I'm going to move us down a little bit later in the activity. It has us changing pages, but here we're going to start to explore the B value.
Okay.
So I am going to change pages to get me a fresh perspective. But here students are going to do a similar thing, and they're going to take a peek at what this B value does.
Ooh, that's not something we explore too often.
It really isn't.
The C value we do.
Go ahead. But what it wants them to do in number 7 is it wants them to write a rule. And so anytime students are asked to write a rule, I think it's a fabulous time for a quick poll. So I have a question here where I'm asking students to simply determine the x-coordinate of the vertex, which is what this is sort of leading them through. Notice this is an expression. So it's asking students to write an expression when I send them to a quick poll, and it allows me the opportunity to determine whether what students are doing is right or wrong, and mark it and score it.
Would you just quickly show that, so for students people are new to the Navigator, would you show the different question options that you are able to insert there?
Absolutely. So
you're talking about this as an expression type, yeah.
Absolutely. So if I come up to insert and question,
yeah,
we have all kinds of multiple choice items that a lot of us can use in some of our other every student response system, but with this we can also do explanation, sort of open-ended, where students can use that keyboard at the bottom to type in responses. But I think the real power of the mathematics is here, where students can enter equations and expressions, and it will take equivalent expressions and recognize them as correct.
Yeah, I really like that ability to grade the students, whether they're right or wrong with the expressions. It's really easy to do that.
Right, right. And I'm going to show you what that I'm going to show you what that looks like in just a minute on my capture. This coordinate and points one is one we're going to look at again in a few minutes. That students are able to enter coordinates and they're able to see what that looks like right on the graph, and you can label it and point on. I'm going to cancel out of that and come back over here to the screen capture. So this would be the results that come back after students have entered that expression. And so when I entered this -v/2, students entered that in all different ways, and it recognizes those as equivalent. And if I were in my Navigator, I could simply right-click and get some options, and I'd be able to mark that as correct, so students can see immediately that, hey, I got it correct. Or if they were one of these people, ooh, I wasn't quite correct, what do we need to do? But I would actually say at this point, in this activity right here, they have just started to explore what the b-value does. This is kind of just a formative situation. I don't think I would mark anything correct here, because what's going to happen next, these next few questions are going to guide students even deeper into that. So what I might do is ask that question again, maybe after number 8 or number 9, when we're getting into the specifics of that x value, to allow students to kind of refine their thinking. And I think by not clicking that correct answer right away, it's allowing us to dig even further into a standard for mathematical practice. And you're looking for that repeated reasoning. We've checked in with them halfway through them looking at the repeated reasoning, but they know they need to refine some things. So these questions, 8 and 9, are really taking students to dig deeper into that standard for mathematical practice. I love the way these worksheets are really thoughtful about how to guide students through that.
I like your idea there, because it's not natural for us. Sometimes us teachers, we tend to want to just give out the answer. It's just what we're used to doing. And so it's sometimes not natural to go through this progression of really having them investigate and explore that a little deeper, and then finally asking that question again and maybe making sure they got to it. I kind of like that. Not showing them the answer makes them you have to think more deeply about it, I think.
Yeah, I love seeing that. Mark just said that he's really bad about his wait time and thinking about that. And doing things like this have really caused me to slow down and think about, in the old days, I would have just marked this correct. This is what you should have. If you didn't, talk to somebody, make sure you know why, and move on. But now we're being more explicit about what those habits of mind that students have to have. That's what those standards for mathematical practice are all about. So we really need to think about how we're planning that to happen in our classroom. It's not just about the content, it's about those thinking.
Hey, Katie.
Yeah.
Sorry to interrupt. We just have one quick question. I was wondering if you could clarify where you're getting these questions from. Are they already created, or are you just creating them on the fly, or are they from a document? Where are you getting these questions?
That's a really good question. So Jeff mentioned earlier the teacher notes that come with these documents. So that's what I'm showing up here. And in the teacher notes, some of these questions are in here. So when you see the teacher tips, the navigator opportunities, and when you look at the end of the document, forgive the quick scroll here, but when you look at the end of the document, it describes what those navigator opportunities are. So it says that you might want to use Live Presenter to do this, or you could do a quick poll, and notice the type of quick poll it's suggesting here, and gives you some questions. But to be honest, some of these questions that I have on here were ones that I just pulled off of that student document and made them into a quick poll with that insert question of capability that Jeff.
So where did you get that document? Where's all this from? I mean, that document that you keep referring to comes from.
So it comes right from the Math Nspired website. So if you go to the main TI website and go to Activities in Math Nspired, and that's the page that I have up now, I believe this one was in algebra.
It was algebra 2. Algebra 2, I think.
Is it algebra 2?
I think so. It was algebra 2.
I believe you.
Quadratic.
Yep, quadratics in algebra 2, which I think is interesting because in Common Core, and again, this depends on how your state does Common Core. Yes, it's right here. That's actually an Algebra 1 concept for us here with Park.
Yeah, I agree.
So when you pull this up now, you have to forgive my computer. It's not the most recent version, but you would see a quick shot here. But over here on this right-hand side is where you have the Nspired document, student activity in both PDF and in Word form, so you can change it, and the teacher notes.
Yeah.
We good? Because I have one more thing that I'd like to show you, everybody.
What's the other
really
thing
cool.
You want to show? Yeah.
So when we get a little bit later in this activity, it starts talking about this axis of symmetry. And I thought it would be really cool if we would send students this question, asking them, actually I think I liked it better this way, asking them to name a point that falls on the axis of symmetry for this function before we even get there in the student page. And so you can see students are just going to put in a point. And when you take a peek at what they do, so a student can put in the point 1, -2, and their point pops up so they have a preview before they even submit their answer to me. But this is the part that I love. When I get to see what all the students are doing, you can see that I can differentiate their responses. But students are starting to visually see that if everybody contributes a point on that axis of symmetry, they're starting to visually see that line. And I think that that is an excellent opportunity to get into the look for and make use of structure. Now here's where those paragraphs really become important, because when we think about look for and make use of structure, without the paragraph, we miss the fact that in the paragraph it talks about students being able to draw in an auxiliary line to help them solve a problem. And I think it's awesome if you start thinking about this as an auxiliary line right there to help sort of show that symmetry, and that gets into that structure piece.
I never really thought about the axis of symmetry being kind of an auxiliary line like we draw in geometry all the time. It's pretty cool.
Yeah, and again, the power of the navigator to help us really get at those standards for mathematical practice. And Jeff, I'm getting ready to turn it over to you, but before I do that, there's one more thing I can't go away without showing because it really excites me. I love looking at the questions on here that have those what-if questions. The what if you do this? What if you do that? And what's going to happen with the mathematics? That just allows students to come back and just kind of go wild and explore and think about what's going to happen as they change these parameters in that what-if situation. Perfect opportunity for your standards for mathematical practice.
Ooh, I wonder if they could try to change the vertex to be what that is. What did it say the vertex was? 1, -2?
I didn't even pay attention.
Or
0, 2.
Could we make the vertex 0, 2? Because I mean, the students, that'd be kind of fun.
That would be very fun.
To get them to a certain spot, that's like kind of a challenge for them.
And perfect way for them to see which parameters really affect how this parabola moves.
Yeah, like if you had them try to get the vertex at 1, 2 in standard form or something, that'd be crazy. I don't know if I could do that. That'd be interesting.
No, but look at what the technology lets us do. By having this technology, they can do it.
They're not afraid to explore, you know, to try things, and they kind of see how things work, and they can come up with their own theories. Sometimes they're a little crazy, but it is fun to let them explore, to have that chance to explore in class.
Yeah, very exciting.
And if I could just jump in for 1 second. So really quickly, I just want to mention how exciting it's been to have the Navigator in my room, especially this year. I have at least one class this year which has been really difficult for me to teach, and I thought for sure they're not going to care about responding or critiquing the reasoning of others, and they're not going to be able to do that politely or respectfully. And it took some time, but the first day that I put the Navigator capabilities in their hands and they were able to respond, it changed the dynamics of that class. They were really excited about having a voice And even if that voice was wrong, I was really careful about how I used that wrong information, and I made that powerful. So I just want to make sure that everyone out there knows that regardless of whether you have your AP calculus class or like my really difficult, struggling Algebra 1 class, I don't think it matters. I think kids just like to have a voice.
Absolutely.
You know, as a teacher, one thing it's helped me to do, Mike, is like you're talking about, it's changed my conversation, my tone with them, because I try to find more things I like, even when they're wrong. I can find some things I like in their reasoning, because you can really kind of see their reasoning, what they were thinking when they're using the Navigator and kind of responding. And it's just a great tool to open up conversation in the classroom, I think.
Yeah. And if you read one of the most recent articles by Dylan William in one of the Ed Leadership journals, I think just in April, maybe March, he speaks to the all pupil response systems as a way to really beef up your assessment and make sure that you're not just assessing your students on who raises their hand first, but that every single student has a voice and you're able to get a clearer picture of what's happening in your classroom because you see what every student's doing, not just the first student that raises their hand.
Yeah.
So, Jeff, are we ready to move on to look at some regression?
Sure. So one thing I wanted to do is we had this idea of talking about regression because I think sometimes as teachers we don't fully understand what the calculator is doing and so forth, and we have trouble explaining things to our students. So I thought it'd be interesting, before I start with the activity I did with my class, to actually go behind the scenes with regression. And so I looked up on the internet there's actually an equation for regression. I actually went through a couple of them because there's different kinds of regressions. I didn't know that. But I stumbled upon the same one that the calculator uses because I kept getting the same answer that the calculator got. And it actually wasn't nearly as complicated as I thought it would be to calculate regression by hand, or at least with the help of calculator here. But I have two lists of data, XX and YY here, and so I just have 3 pieces of data in each list. And I just had 3 more lists that I added to this, and so it's kind of like an Excel spreadsheet. This is the listed spreadsheets app on the TI-Nspire, and so right there in the second line, you can put a formula. So I put XX times YY. I basically just multiplied the X and Y column, so 1 times 3 is 3, 2 times 5 is 10, 3 times 6 is 18. And the next formula
Hey, Jeff,
bar
I have a question.
Yeah.
Why do you call this XX and this YY?
It's a great question. I try to avoid trouble in my class, and if you just call it X or Y, there's actually a column X and Y further down to the right. And so when you put X and Y in there, the calculator doesn't know, are you talking about the column X or the variable X? And so it gets confused. And so I always use at least 2 letters for any title, which is basically a variable in your calculator. So I always name it with at least 2 letters. That's why I do that. And so
that's what happens when I try to use a variable and it says X, it's asking me, is it a column in the spreadsheet or is it the variable? So good to know to always use 2.
Oh yeah, always use 2. And the next column is just an X squared. So I took all the X values and squared them by putting X squared there. And then the next one is Y squared. So I took all the column of the variables in the Y column there and squared those. And so if you just sum up all 5 of those columns, you just the sum of all the X's, sum of all the Y's, sum of the XY's, if you add all those together, that's what you need to do the formula. And I didn't know it was as simple as that. And so if you go to the next page, I put an interactive notes page there. By the way, this document is available to you since you signed up for this WebEx. And you can see here, I just put the sum X is equal to the sum of XX. That's just Excel command that I use to sum up all the X6, 1 plus 2 plus 3, and the sum of all the Y's. And I summed up all the 5 of the columns. In the top right there, I just used a programming command called count. And so I said count all the variables, how many terms are in the XX column, and there were 3, because that's part of the formula. You had to know the n value. And so at the bottom, I have 2 equations there, which really give me the y-intercept and the slope of the regression line. So if you see that y-intercept there is 5/3 and the slope is 3/2, And what's really nice about this notes page is it will automatically update even when I change values. If you go to the next page, if you add could you add a data statistics page? I just want them to show them that this actually is the regression equation. And this is always, kids always like doing data statistics. If you hit tab, you can go to XX there and hit tab again and go to YY. So if you do a regression with those 3 points, you just go to Menu, Analyze, and you'll see regression there. I teach AP Stats now, so I always do A plus BX now instead of MX plus B. It's the same thing, just a little different order. And you can see that the y-intercept is 5/3 and the slope is 3/2 there. And so it does match. If you click on the line again, it'll show the equation. But it does match the values we just got. And if you go back over to page 1.1 for a second, and just add one more point there, like 4, 10 or something like that. 4. And when you add 10, it'll take away those errors because it has the same number of x and y values. And if you go back to the next page, you'll see that the regression, the y-intercept is now 1/2, and the slope is 11/5. And if you go to the third page, you can see that that equation is also changed. And you can see the regression line there. I just like that the Nspire automatically updates. And I don't know if you all have, maybe you all are familiar with this, but I did not realize that, it's just an equation. It's not as complicated as I thought. I thought the calculator, when it calculated regression, was doing kind of magic in there. Did you ever know what that equation was, Katie?
I didn't. I had done these types of calculations before, but I don't think I ever made the connection that this was the regression equation. And I think it's really important that your students sort of have that background understanding of where does it come from? Why does that happen? Instead of thinking it's a magic box.
I mean, I don't know. What do you all think in the participants here? I wonder if you would actually share this with students or not. I thought it was interesting for me as a teacher. I like to know more than the students sometimes. I usually try to. Sometimes in AP Stats this year that wasn't true. But so I don't know if it would work with students or not. I think Common Core is about knowing things at a deeper level, and certainly there's a lot of stuff about regression. I think it's kind of interesting for me. I wonder if students would be interested by this.
I don't know that students would be interested, but I think it's our job to make sure that they do have that understanding. And I think that not only does it allow them to more deeply understand the specific content standards, but by asking them to go through this process, it allows them to engage in those standards for mathematical practice so that they have that deeper understanding and they know how to reason quantitatively and what those what the relationship is amongst all those points and how this regression equation comes up.
What are some of the standards related to regression? Do you have any of those available?
I think I did happen to pull some over.
So what grade level are these standards active?
So since they're high school standards, it really does depend on your state and how they are choosing to do this. But I do know that Park, and again, because I'm a Park state, I know what they do. I don't know what Smarter Balance does. But in Park, these are part of Algebra 1. So this is now all part of that content that my Algebra 1 students need to be proficient and fluent in, is having this deep understanding.
So they actually get into residuals as part of the standards. They have, you're doing a regression line, basically, a line of best fit there, a linear function that fits the data. Even quadratic and exponential models. It's interesting.
Absolutely. They need to be able to look. They need to be able to look at that function and sort of try to informally decide which one of those regression equations or what they think is going to be the best function to fit that.
I mean, so the thing that I've noticed, and I don't know if you've noticed this, in the last couple of years, stats has been creeping into Algebra 1, it's been creeping into Algebra 2, even geometry. It's part of our standards now. So if you don't run into this at some point, you probably run into it in some of the classes that you're teaching that you're going to have to teach some of this stuff in some of your classes, I think. It's just part of the new standards. And I know there's a lot for us to teach, but this is part of it in many cases.
Yeah, well, and I think part of that's because, statistics is what, as a contributing member to society, you need to be able to look on statistics and really make sure you know what you're talking about there.
yeah, let's go ahead and go to the activity I did with my class. So I sent them this document right here, and it just has this first page, which was some data, the height of male AP Stat students and the weight of male AP Stat students. I teach in an all-female school, so anything with males is kind of interesting here. And so I sent them this data, and so I had them insert a page and graph it, the scatter plot, and then do a movable line. If you would do that for me right now, Katie, would you insert a data statistics page? And then I think it was height of the male, and then weight of the male was your Y response variable there. So the data looked like this. That is one ugly spreadsheet.
I mean, that's one ugly graph.
It's got a lot of stuff there. So I told them, I asked them if they would just add a movable line, which I think is under the Analyze menu there. Add movable line. And it's kind of a really neat feature. You can grab it. The students can, on their own handheld, kind of grab the line on the end, and it'll kind of twist it. And if you grab it near the middle, you get a different kind of icon. It's kind of a crosshairs there, and you can kind of move and change the y-intercept without changing the slope of the line. And so I wanted them to kind of, just given that data, try to do a line of best fit and just do it the best they could. And I had a few students who had some interesting results.
So Jeff, this reminds me a little bit of that old uncooked spaghetti noodle type situation, if you ever did that in your class.
You can do this with spaghetti noodles or whatever. I was just using technology for this so that everyone could see everyone else's screen. So that's one of the nice things about the screen capture is the ability to, if you scroll up a little, to see each other's screens. And so if you look at Alexa's screens, it's a way for me to start conversations. So I showed her screen to the class, and I said, okay, what was your reasoning for this? And so I was trying to get her to construct her viable arguments here. What was her reasoning for putting the points where she did? She said, well, my line, I wanted to go through as many points as she could. And so she went through the 6 or 7 points at a time. Of course, that doesn't always give you the best line of best fit there. But that was kind of her thinking there, was to go through a lot of the points. It's interesting because really when you think about a regression line, it doesn't have to go through any of the points to be a regression line. So there's some flaws in the thinking, but there's some good things in the thinking. If you scroll down a little, I think it's always interesting. I think this is how Navigator helps me, is to get them to get into their thinking, to see what they're thinking, to get them talking about it. So I showed Jennifer's screen and asked her, okay, tell me what's happening here. And she'd actually been taught in middle school, and I think some books do this. I've actually seen some of this in a math textbook before. Basically just tells you connect the top right point and the top left point and draw a line. And that's your line of best fit. Of course, that could be problematic. Do you see any problems with that strategy, Katie?
Well,
just connecting the top right and top left point.
In this case, it doesn't look horrible, but in other cases, that line could be nowhere near the rest of the data. I can completely see this line being just parallel to it and maybe up here somewhere, where it's not going to be at all representative of the data. So it does not make it a good situation for students to make predictions and reason about the math.
And so then if you scroll down a little more, I had one more student I wanted to show you. She had something interesting. So Lily put it here, and she said she tried to put, I thought it was a good, interesting reasoning, about the same number of points on each side, which isn't necessarily always true with a regression line, but it's something to think about. It was interesting how the student thought, well, that makes sense. It just put equal number of points on each side. But if you go back to the TNS file, of course, you could probably, Katie, move that around, and so that there would be a roughly equal number of points, but the line of best fit would not be that's not a very good line of best fit there at all, but yet it seems to be somewhat about half the points are on each side of the line, so that's not always a good strategy either. So then it got really,
I'm sorry, that makes me think about how important it is to, again, think about your attention to precision, that we need to think about the words that we're saying to our students, or helping them clarify the language they're using. If they say, you know, I put half of my points under and half of my points over, we need to make sure that we're helping them refine that and in that attention to precision.
Yeah. And so since residuals are part of the standards there, and certainly was part of my class, I wanted to teach them about residuals. And so I started by doing, this is a really neat thing. If you right-click on the movable line there, you go show residual squares. And what happens is these squares come up, and so the regression line is often called the least squares regression line. And so if you move that over just a little, you can see the goal of my class then was for all of them to try and get the smallest sum of squares. So move your line in such a way that you minimize the sum of squares. You get the very smallest sum of squares there. So they very quickly figured out, you know, how to kind of move their line around so those squares got a little smaller. The area of those squares was smaller. It's a great built-in feature. It's a real good visual for them. This is actually, I like combining collaborative things with competitive things sometimes, and they love this because they were very competitive. They wanted to just move it around, and I'd use screen capture using Navigator, and I could, you know, highlight, you know, oh, you know, Kara's got the lowest sum of squares right now. She's at 6,400, you know, and so then, oh, that just motivated everyone else. And so they're moving their line around. They're seeing where other people are putting their line with the screen capture on Navigator. And so you're able to kind of make a better choice about how you move that line, whether you move it up or twist it or so forth. And so that's kind of a big idea, and it introduced them to roughly to the idea of a residual. And so I wanted them to kind of understand the residuals a little better than this lets you do. So if I go to the next page there, I took some more data, xc for x coordinate, yc for y coordinate. And off to the right there, I just did two things. I found the average x value and the average y value. X bar and y bar is how we say that in stats class. But that's actually a very interesting point. It's something that students should know about regression. The regression line always goes through the point x bar, comma, y bar. It always goes through that. Did you know that, Katie, that the regression line always goes through that point?
I did not know that until just a couple of weeks ago at a workshop that I attended at a conference.
Yeah.
And so no, I didn't know that.
So I built a page on the next page that kind of highlights that. And so this line is movable. You can grab it and move it, but it always goes to the point x bar, y bar. And if it does that, the residuals there will always add up to 0 as long as it goes to the point x bar, y bar. And so the way I built this document, you can see that the red lines are the negative residuals. The students remember in my class, I don't know if you all use you know, memory tricks to help them remember things. And so we say RAP. RAP stands for residuals equals actual minus predicted. So the predicted is the value, the y value of the regression line there, and the actual is the data point, the y value of the data point. So it's actual minus predicted. So if you have a smaller number actual, it'll be the negative residual, and if the data point is above the line, it'll be a positive residual there. And so
this number down here, the negative 2.61 is
the length of that line. That's the
length of that
difference in the y value between the predicted and the actual.
That y value minus the y value up here on the line. Nice.
Correct. Yeah. And so this was just a file they could play with and see that the residuals always add up to 0. What a positive residual. I like that if you move that line wildly up, the negative residuals will become positive and the positive ones will become negative, and so they actually change color. I like that you can kind of do those neat kind of little features and explorations using TI-Nspire.
There's what-if questions, yeah.
Yeah, so what if, you know, what if we moved the line there? What would happen? And so I thought this was a good way to get them kind of active and doing something rather than me just standing up there and teaching them one line that doesn't move and what this means. They can actually play with this file and see, what happens when you move that, what happens to the residuals, and what happens to that movable line, I really think is a good way to introduce some of those things and get them really critiquing each other, and constructing arguments about how the function fits the data. It was really interesting to have those conversations about what were their misconceptions, how did they think a line of best fit should be put on there. Because it is hard to say. I mean, what's the best response to that? What is it? How are we supposed to do that? So I was asking a question that's kind of loaded.
Yeah, and that brings us right back to the content standards. You mentioned the standards for mathematical practice, but these content standards that this SID B6B that students have to be able to assess how good is their function fitting, and what kind of, do I have a good function for the data that's representative of my data, and residuals is one of those things. So I think that's an excellent activity.
Yeah.
Jeff, I think we're starting to run a little close on time here, so we might need to toss it back over to Mike.
That sounds like a good plan.
Okay. Mike, you ready for that?
I'm ready.
Okay, and while we're doing that, Mike, if you don't mind, I'd like to say just one more thing, and that being that Jeff and I have talked about so many different ways to use just one activity to pull out those standards for mathematical practice. And rich tasks have access to so many standards for mathematical practice. Sometimes you could get all 8 into one task. But we need to make sure that we're being purposeful about planning for those standards for mathematical practice, and we probably want to only plan for 1 or 2 in our classroom so that we can be purposeful with our students and explicit in that instruction to be able to build their capacity in each and every one of those standards for mathematical practice.
I knew you'd say that at some point, Katie. You always remind me of that.
I think it's really important. Rich tasks do have everything, but we have to be purposeful in how we plan that.
I agree.
So, Mike, I think it's all yours.
Thanks so much. As we conclude here, if you have any last-minute questions for Jeff or Katie, please feel free to use the chat or the Q&A window. I do want to share at least one resource that we have available on our website. I know a few people earlier were asking about some sort of basic information as far as using TI-Nspire or using maybe TI-Nspire Navigator if you're sort of new to that technology, where you can go to get some really good free resources, and they're available on our website at education.ti.com. And specifically, if you click on the Professional Development tab and move down to Online Learning, on the left-hand side, check out Tutorials. And you'll see in the middle here we have some Atomic Learning tutorials, and so my friends over at Atomic Learning have done a great job of putting together some really short videos that are free, that are specific to the default here is the TI-Nspire and TI-Nspire CAS technology. But right below that we have TI-Nspire Navigator, and so just for fun, I'm going to click on that and see what's available. So you can see there's 9 short videos just for the TI-Nspire Navigator in case you forget how to do some of these things. Again, they're free, and you can pause and rewind those as needed. So I want to make sure I showed that, especially if you're new to TI-Nspire Navigator or just TI-Nspire itself.
In some of the webinars that are archived, I've got 3 of those on there from a couple summers ago that are, if you search my name, you'll find those, that are out-of-the-box Navigator.
That's a great point, Jeff. Let me show that as well. So also under Professional Development, also under Online Learning, on the left-hand side, if you go under Webinars, Jeff, I think what you're mentioning is the on-demand webinars, right? And so what Jeff's mentioning is we have...
F, like if you just do a Control F, like and do McCalla, and search, it'll probably pick up. I think it was with Ray Lesneski.
Yeah. Jeff, you've done a lot of these. There it is.
Yeah. There you go. That's one of them. 626. So right there, there's about 2 or 3 of them right in a row. That are out-of-the-box Navigator. There you go. Those 3.
Thanks for that reminder. So the great thing is that all of our webinars are recorded and are available on demand, even ones all the way back to, say, 2012, and actually before that as well. So feel free to check those out. When you leave the webinar, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events such as our summer and fall webinar series. So if there are any things that you'd like to see specifically, maybe this fall, whether it be a technology or content, please let us know. We definitely listen to your feedback, and we really hope you share your thoughts in the post-webinar survey. To receive a certificate of attendance, go ahead and click the link in the chat window. That contains the name, date, and duration of tonight's webinar. All the documents used tonight by Katie and Jeff are also available there. In case you miss it, either the certificate or the documents, you'll receive an email here in a few days that will contain all that follow-up information, also link to the recording, the documents, and the certificate. So if you miss it tonight, no big deal. You'll get it here in a couple days in a follow-up email. So thank you so much, Jeff and Katie. I saw already in the chat window there's been some thank yous pouring in. So it's nice to see that. I think a lot of people have resonated with some of the things that you shared with us tonight, and I really appreciate all the time that both of you did put into making this webinar a huge success. Thank you so much.
Hey, we appreciate all the people who want to learn right before the summer break here. Very dedicated teachers who showed up today. So.
Absolutely, this has been great fun. I've been loving watching the chat that's going on. I'm anxious to get back and look more in detail at what they were all saying. So, thank you, everybody. Have a great night.
Thank you.
I'll third that. Thanks so much, everyone, and we hope to see you back online next week.